Hi there. Okay, I'm getting ready to do the iodine clock reaction. So I just wanted to start off by showing you all the ingredients that I've gathered right over here. So you can see I got my vitamin C, hydrogen peroxide, distilled water, cornstarch, iodine tincture. I have some coffee filters here for filtering, and I bought this funnel from the dollar store. It's kind of big, so not really sure how well that's going to work out, but we will just have to wait and see. So I'm going to start off here. I was not able to find 1,000 milligram vitamin C, so instead I got 500 milligram vitamin C. So instead of using two 1,000 milligram tablets, I will use 4 of these 500 milligram tablets. So I already started crushing the tablets with a spoon because I started recording and I found out that it's a lot harder to crush them than I expected. So I've crushed them up for the most part. So now I'm going to place them into my cups. I'm living in the Airbnb and we don't really have cups, so these will be utilized as my cups or beakers for this experiment. So for the first solution, like I said, I'm going to place the vitamin C that I've crushed up into the cup, which is what I'm doing right now. Make sure that I get it all in there. And now I'm going to add to the vitamin C 60 milliliters of distilled water. Now I am going to stir this here for about, I don't know, 30 seconds or so. Stir it for about 30 seconds. This is trying to dissolve the vitamin C into the water. But there's a lot of fillers in the pill that are not soluble, so we shouldn't expect the vitamin C to totally dissolve. It's going to still be cloudy, and we shouldn't worry about that too much. Okay. It's been about 30 seconds, so I'm going to stop that. And I'm going to pour the solution through a couple of coffee filters. And that's filtering. I'm going to move that off to the side and start making the second solution. I'm just making sure that I'm drying this out really well. Like I said, I apologize, I don't have more cups, so kind of working with what I have. And for our next solution, we're going to use about 4 grams of cornstarch, but as they said in the video that you posted, it doesn't have to be like super precise. This is about how much that I saw him use in the video, so that's how much I want to use. I'm going to put that in there. And then I'm going to add 350 milliliters of distilled water. can see, kind of can see, this is about 350 milliliters of water. So I'm going to put that into my cornstarch and mix it up. And then this solution B, we're actually going to pop it in the microwave, and it says to heat it until boiling. So I'm just going to start off with a minute and see what that's at. Looks like solution A has finished filtering through the coffee filters. We'll just leave that alone for a second. Check on this. Not quite boiling. Waiting. Okay, I see some bubbles, so we're going to say that's good. And now we're going to filter solution B through 4 coffee filters. This funnel is actually working a little bit better than I thought it was going to, so that's good. Taking a little bit of time, sorry. It's almost there. Alrighty. Okay, so to finish solution B, we're going to next add 150 milliliters of hydrogen peroxide. Okay, solution B is all done. And now let's go back and finish solution A. So last off at solution A, we filtered the vitamin C. Next, we need to add our iodine tincture. When we add the iodine tincture, the solution should remain colorless. The iodine tincture is I2, and when it reacts with the vitamin C, it's going to convert to I- or iodide, which is colorless. So I poured in the iodine tincture. As you can see, it has remained colorless. It is completely clear. And then after that, we're just going to top off the solution with distilled water. So it's about equal in volume to solution B, roughly. Give or take, they're about the same. I might have poured a little bit too much distilled water into solution A just right now because that gallon's a little bit heavy, but they're about roughly the same. So next we're going to add equal amounts of solution A and solution B into a glass. And when I do this, we should expect that a sudden color change occurs, but it might take some time. So just before I do that, in solution A, we have a mixture of vitamin C and colorless I- or iodide. And then in solution B, we have hydrogen peroxide and starch. When these two solutions are mixed, two reactions actually should begin to occur and compete for one another, excuse me. So the hydrogen peroxide is going to want to oxidize the iodide in solution A back to colored iodine. But vitamin C, or ascorbic acid, wants to reduce the iodine I2 back to I-. Okay, so this occurs very quickly. Eventually, vitamin C is going to be consumed because there's an excess of hydrogen peroxide present in this reaction. I2 will start to accumulate and combine with I- to form triiodide. Triiodine. Triiodine is going to combine with the starch to produce a blue solution, which is what we should see here in a second when I combine the two. A blue solution of triiodine and starch. The concentration of the reactants and temperature of the solutions are going to affect the rate of this reaction. Like we talked about in our other lab that we did, there are 4 things that affect the rate of reaction, and in this experiment, the concentration and the temperature are 2 of those things. So we should expect that the color change will occur faster if we increase the concentration of iodide or hydrogen peroxide, and the color change would occur slower if we increase the concentration of vitamin C. Since we know that temperature also affects the rate of reaction, this reaction would go faster if we increase the temperature, if we put it in the microwave and boiled it. Vice versa, if we cooled this reaction, these solutions, it would occur slower. Let me grab a glass really quick, and then we can do the parts of each solution. And hopefully we will see a color change. So I think what I'm going to do so that it's equal parts of each solution is, since I'm not great at eyeballing, I'm just going to measure out 120 milliliters of each solution and then pour it in here, so that I know that I have the same amount of each. First I poured